Hi everyone, welcome to Conceptual Thinkers Talk Primary Math Concept with teacher Ben. So today we will be touching on P6 CHIJ SENIC SA1 2022 Paper 2 Question 15. So let's start. Okay, just from the question you know that it will be a number pattern question. So the reason why I want to do this question is because one of the part I feel that is quite challenging for the student. So I think it's good to have some practice before we go into SA1 test, okay? So let's start. So let's interpret the question first. So there's some small triangles and dots are used to form figures that follow a pattern as shown below. So we have figure 1, figure 2, figure 3, figure 4. Now the good thing is they actually provide a table here. So if the question didn't provide any table, so I strongly suggest to do something like this so that we can see some number pattern in terms of their changes to the next figure. Okay, so we have figure 1 for the first column, so 1, 2, 3, 4, 5. Then for the second column, we can see the number of small triangles. Then from 1, 4, 9, 16, 25. Now, I feel that these numbers right here that are mentioned right are actually very common numbers. These are actually called square numbers. So why is it called square numbers? Because it's the same number times same number. So in this case, it's 2 times 2, then 3 times 3, 4 times 4, 5 times 5. Now, if you want to be good with number patterns, what you need to do is you need to link your figure number with your calculation for your other columns. So in this case, you notice that the number that is used here is 1, and it linked to the figure number as 1 also. So here is 2, here is 2, 3, and 3. So from here, right, we can actually handle any figure number to link to the number of triangles. Okay. Now next, we have number of dots. So we start with 3, 6, 10, 15. So the best guess here is to see whether is it addition or multiplication. It can be a multiplication of 2, but when we take 6 times 2, it doesn't give me 10. So in this case, I will try with addition. So you notice that it will be plus 4, and with addition of 5. So it's actually incremental, right? So next I will expect it to be 21. Okay, so this is how I'm going to fill up for part A. So if you continue with the question, the table shows the number of triangles and dots for the first 4 figures. So for part A, we need to complete the table above with the number of dots in figure 5, which is what we have done. Okay, next we need to find the number of small triangles in figure 9. Okay, so small triangles, which is the column 2, then for figure 9. Then lastly, we need to find which figure will there be 91 dots, which is for the third column. Okay, so the concept here will be number patterns. So you can actually look at other video that I created for number patterns. Okay, so we already identified the concept. So now let's focus on part B. Now they want us to do figure 9, right? So since we know that the number of triangle is actually depend on the figure number multiplied by the figure number. So for part B, we can just take 9 times 9. So the answer will be 81. The reason is because when you look at figure 9, in order to get the number of small triangles, we just need to take 9 times 9. Okay, so that's how we get 81. Now the next part will be the difficult one, which is to look at column C. Now, so let's analyze how to actually get column C. I use another color. Adjust a bit. Okay. So let's look at this. So this is 3, this is 6, this is 10, this is 15, this is 21. Actually, these numbers are quite, I would say that is also common, but usually not in primary level, but in secondary level. Now, if you look at the numbers, they increase by incremental by 1, right? So what I mean is this addition of 3, then the next one will be addition of 4, addition of 5, addition of 6. Now, from this, we have to link it with something called triangular number. Okay. So if you can't remember, you can't actually execute the step to get to triangular number. Now what I would like you to do is to memorize the formula. Now, there's a lot of variation for triangular number. So the most common one they will use will be n times n plus 1 over 2, whereby the n actually linked to our figure number. So the figure number will be n. So let's try for the first one. Now, if the figure number is 1 and I use n as 1, will I get to number 3? The answer is no. So then you will say that, hey, why should I use this formula since it's not getting it to what I want? So if I put 1, this will be 2, right? Because n plus 1 will give me 2, and it's a bracket. So according to the order of operation, I need to calculate this first. So 1 plus 1 will give me 2. So 1 times 2 will give me 2, and 2 divided by 2, because when you do a fraction means we are doing a division. Okay, so we divide by 2, that will give me 1. So it doesn't work. So what I need to do is I need to change, or I need to make some changes to the formula. So one way to do it is because I need more numbers, I need the number to be bigger. So I will not use n, I will use n plus 1. So let me try with n plus 1. So which means that if it's figure 1, I will use 2. Okay, then I will multiply by n plus 2, which means that this number, instead of having 1 more than the figure number, I want it to be 1 more than the figure number, sorry. So that's why I change it to n plus 2. Then I divide by 2. Then let's see what will happen. So when n is equal to 1, this will be equal to 2, and this will be equal to 3. Then if I multiply, then I divide by 2, you notice that I will get 3, because you give me 6, or you can cancel the common factor. Then you give me 3. So it matched to the first number, right? Yeah, so good. So what I'll do is I will try with another figure. So let's write it down first. So this will become 2 times 3 over 2. So this one will be 3 times 4 over 2. Oh yes, I'm going to get 6, because I will get, you notice that n is actually 2, so I will be n plus 1, that will give me 3. Then 2 plus 2 will give me 4, so 3 times 4 over 2, that will give me 6. So let's try this. So this will be, figure number is 3, so I will need to use 4 times 5 over 2. So 20 divided by 2, that will give me 10. Then let's try this. So 5 times 6 over 2, then 30 divided by 2 give me 15. Last one, let's try this. So we take 6 times 7 over 2, so it will give me 42 divided by 2, so that will give me 21. Okay, so this means that this formula works. This works. So I'm going to use this formula to actually get to the answer. Okay, so I know that n plus 1 times n plus 2, if I take the whole thing divided by 2, that will give me 91. So it looks like a very complicated formula, right? Okay, so don't worry, I will teach you how to actually do the calculation later. Okay, now this whole thing is divided by 2. So what I do is I don't want a division of 2. So I'm going to remove the division of 2. So to do that, I need to introduce a multiplication of 2. So I need to multiply by 2 to both sides, so that it will cancel out. So these 2 will cancel this. Okay, so that means that n plus 1 times n plus 2, that should give me 182. Now then, this is tricky, because in primary level we didn't learn this. So this is basically one number times 1 plus another number. That should give me 182. So the way to do this calculation is, first I will use a square root. So you can use your calculator to do a square root of this. So what is the function of square root? Square root is actually using the same number times same number, right? Okay, that will give me this. So I will use my calculator here. So what I do is I will just do a square root of 182. So once you do the square root of 182, you will get 13.4907, and you get a very whole big number. Now this means that if you look at the number line, it will be between 13 and 14. So 3.1 will be around here, 3.4907 . Okay, so what you're going to do is, you're not using this number, you're going to use for 13 and 14. Okay, now so this means that my n plus 1 is equal to 13, or my n plus 2 is equal to 14. So is it really true? So what you can do is, if you take 13 times 14, that will give you 182. So let's try with our calculator. So if we take 13 times 14, yeah, it'll give me 182. So now, if you want to find out what is your figure number, which is your n, right, you can actually bring this over and you do a n equal to 13 minus 1, or you can do a n equal to 14 minus 2. Now you notice that you're going to get 12 for both cases, get 12. So this means that the figure number that you will be getting will be 12 for dot 91. Now, so how do I know that whether my answer is correct or not for part C? Now the only way to do it is we have to do listing. We have to keep listing it out. Okay, so what you do is you will keep listing, or you keep doing this until you hit 91. Now they give you 91. The reason is because it's not so difficult to list out. Now I always tell my student that when you do a number pattern question, in case you're stuck, because sometimes the formula can be very complicated, then what you need to do is you just list out. So if you continue and list, right, so what you will do is when you hit 13 times 14, then you divide by 2. From here you're going to get 91. And remember, when it's 13, what will happen to your figure number? It will be 12. Okay, so this is the way that I will implement my steps to solve this number pattern question, and also use the listing out to actually do my inspection. Okay, so this is what I have for you for this question. So don't forget to follow us on our YouTube channel, Conceptual Thinkers. Then follow us on our Facebook, Conceptual Thinkers Mathematics and English Hub. And also can follow on our TikTok, Conceptual Thinkers SG. So feel free to let us know if you have any question. You can share your feedback and comments in the comments box below. Then we will get back to you. Okay, that's all for this video. So I'll see you in the next video. Bye.